All right, we've been playing with absolute value functions and solving absolute value equations and inequalities, but now we want to graph an absolute value function. So far, we've been working with two definitions for absolute value. The first definition is that absolute value is a distance. It's the distance that a number or an expression, whatever's inside the absolute value, the distance that is from zero. And that also led to our piecewise definition that said the absolute value of x is x if x was already positive. But if x was negative, then the absolute value is going to be the opposite of x, which makes sense because if we take the absolute value of 10, that's 10. But the absolute value of negative 10 is the opposite of that, positive 10. Let's use that piecewise definition to see what the graph of absolute value looks like. So we know that absolute value of x is x or the opposite of x. It will be x if x is already greater than or equal to 0. And it'll be the opposite of x if x is less than 0. So when we graph a piecewise function, remember that we do it one piece at a time. So let's take the first piece, x. So we're going to graph the line y equals x. That has a y-intercept of 0. And a slope of 1. The graph of that line looks like this. Now we want to keep the part where the x-coordinates are positive. So I'm going to take all the stuff that's to the left and erase that. Next, we'll graph the second piece, the negative x. So of course that means we're talking about the line y equals negative x, which has a y-intercept at 0. And a slope of negative 1, so down 1 over 1. That line will look like this. Of course, that's only when the x-coordinate is less than 0. So for the negative side of the x-axis, which means we're going to erase this part. And we see that the shape of the absolute value is going to be this very distinctive V shape. It comes to a very sharp point at the vertex, which in this case is at the origin. So let's try that again with a slightly different absolute value function. F of x equals absolute value of x minus 5. So our first thing is going to be to rewrite it in terms of the piecewise function. Now remember, absolute value is going to equal what's inside, x minus 5, if what's inside is positive. Or it'll be the opposite of that, if what's inside is negative. We can kind of clean this up a little bit. The first one, when we're looking at x minus 5 being greater than or equal to 0, we just add 5 to both sides. And we're talking about x being greater than or equal to 5. In the denominator, or in the bottom piece, we'll distribute the negatives. So we'll have negative x plus 5. And that will happen if x is less than 5. So now let's graph each piece. That's going to be the line y equals x minus 5. So that has a y-intercept of negative 5 and a slope of positive 1, giving us this line. And of course, we don't want the entire line. We only want the portion that is greater than or equal to that 5. So I'm going to erase everything that's less than that 5. And there's the one piece. Next piece. We're talking about the x, negative x plus 5. So y equals negative x plus 5. That has a y-intercept of positive 5 and a slope of negative 1. Here's that graph. And of course, we want to keep the piece that is smaller than that 5. And we get our distinctive V shape again. Comes down to a vertex right at that 5. So one thing that should stand out to you is that that vertex happened right here at 5, 0. And it just so happened that there's a 5 in our equation. And actually, if we were to plug 5 into x, we would get 5 minus 5, or 0. The absolute value is 0. So wherever we have the absolute value of 0, that is where we're going to get the graph to turn around. That's where we'll find that vertex. So here we have g of x is equal to absolute value, 2x, and then we'll subtract 4 outside of the absolute value. We just said that what made 0 inside of the absolute value, that's where the vertex happened. Right? And what's going to make 2x equal to 0? But 0. So if we plugged in 0 for x, we would get absolute value of 2 times 0 minus 4, which is 0 minus 4, or negative 4. What this tells us is that we can expect our vertex to happen when the x-coordinate is 0 and the y-coordinate is negative 4. That's what our expectation is. Let's go back to using that piecewise definition in order to prove that. So for g of x, the piecewise definition would be that absolute value of 2x is going to be 2x or negative 2x. We also have to subtract 4 on each of these. It will be 2x if 2x is greater than or equal to 0. It'll be the opposite of 2x minus 4 if 2x is less than 0. When we simplify this, our equations are going to stay the same. The 2x minus 4 part will stay the same, and the negative 2x minus 4 will stay the same as well. But we have to divide by 2. So that will be when x is greater than or equal to 0 or less than 0. Kind of interesting that we're talking about x being 0 when we have x being 0 in these parts, and we anticipated that our vertex would happen when the x-coordinate is 0. But anyway, back to the graph. First, let's graph the first piece, y equals 2x minus 4. So y-intercept is negative 4, and now we have a slope of 2, so we go up 2 over 1. That will give us this for our graph, and we want to keep the piece that is greater than or equal to 0, so we will erase the piece that is negative. Now, for the second half, y equals negative 2x minus 4. That also has a y-intercept of 4, but a slope of down 2 over 1, or up 2 and back 1. Graphing this line, and we want to erase the piece that is greater than 0 because we are keeping the piece that is less than 0. And there we get our V shape again. Notice, where did our vertex end up? It was right here at the point 0, negative 4, just like we expected. So the negative 4 on the outside actually shifted that vertex down to negative 4 for the y-coordinate. What did this 2 do? Well, check out the slopes of each side. On the red side, we went up 2 and over 1. That's a slope of 2. And on the blue side, we went up 2 and back 1. So that's the slope of negative 2. So whenever we're going to multiply that x, just like when we were dealing with a line, that was the slope. It's just with absolute value, we'll have one side be the positive slope and the other one be the negative slope. The main thing that you need to understand right now, though, is that the shape of the absolute value function is that V. Where it comes from is the piecewise definition. You graph each half over each interval.